The other aspect of the equilibrium reaction will now be factors affecting equilibrium reaction. There are some factors that will affect the equilibrium reactions. What are the factors that affect equilibrium reaction? The factors that affect equilibrium reactions are the pressure of the reaction or the reactant. We have concentration. We have from concentration we have the temperature, and we have catalyst. These are the major factors that will affect equilibrium reaction. Now what we do is, how can pressure affect the equilibrium reaction? We look at them one after the other. But a senior scientist was able to now discuss the effect of all the 4 factors I have listed. The scientist that took his time to highlight the factors, these factors, was Le Chatelier. Hence the name or the principle became Le Chatelier's principle. So the scientists that studied the factors I have listed here was known as Le Chatelier's. The principle he advanced or stated was known as Le Chatelier's principle. And Le Chatelier's principle stated that if the factors that affect equilibrium, which are pressure, concentration, temperature, and catalyst, if those factors are altered, the equilibrium will readjust itself in order to lessen the change. Le Chatelier's principle states that if the factors that affect equilibrium reactions are altered, the equilibrium will readjust in order to lessen the change. That was for scientific interpretation. Let me now come to the lower point for people to get it clear. What does that mean? That anytime one of these conditions or these factors is increased, the equilibrium will try to reduce it. Anytime one of these factors again reduces, the equilibrium will try to increase it. So that is why the principle states that when the factors are altered, the equilibrium will readjust in order to lessen the change. So if those factors are increased, the equilibrium will reduce them. If they are reduced, the equilibrium will increase them. That is Le Chatelier's principle. Now we are going to look at these factors one after the other. We'll look at the effect of pressure, we'll look at the effect of temperature. Let us look at the effect of pressure on the equilibrium reaction. We now look at the first factors that will affect the equilibrium reaction. That will be the effect of pressure on the equilibrium reaction. Effect of pressure on equilibrium. We are using Le Chatelier's principle to advance now the effect of pressure on the equilibrium reaction, which says when the factors that affect equilibrium are altered, the equilibrium will readjust itself in order to lessen the change. Now let us look at pressure here. For you to be able to understand the pressure analysis, for you to be able to put things in place, to explain the effect of pressure, you look at Boyle's law. That means the effect of the pressure will be explained using Boyle's law. We use Boyle's law to explain the effect of pressure. And what is Boyle's law? Boyle's law states that the pressure is inversely proportional to the volume, provided the temperature is constant. That means the pressure is inversely proportional to the volume. The more you apply pressure, the more the volume reduces. Like this one, you see the volume is very large here. When I apply pressure on that, the volume will reduce. That means the higher the pressure, the lower the volume. The more you apply pressure on something, the volume becomes very small. And when you remove pressure from that particular system, the volume will increase. That means when you press something, the volume reduces. When you now remove the force, the volume increases. That tells you that the volume is inversely proportional to the pressure. Increase in one will lead to decrease in the other. So for you to be able to advance that, we make use of Boyle's law. That law must be understood. That increase in pressure will lead to decrease in volume. Now, pressure will only affect gaseous molecules. Pressure affects gaseous molecules. That means for you to be able to discuss the effect of pressure on equilibrium reaction, all of the molecules involved must be gaseous. They must be gaseous. That means all of them are gases. For pressure to affect a particular reaction, the reaction must be, all of them will be gaseous molecules. The effect of pressure again has no effect pressure has no effect on equilibrium reaction when you have equal volume of reactant and equal volume of product. So pressure has no effect. Pressure has no effect when when there is an equal volume of reactant and product. When there is an equal volume of reactant and product, how can you advance that, or how will you be able to interpret that? Let us say we have an element A plus an element B. They combine under the equilibrium to produce a compound known as 2CD. Now when you look at this, the value that is in front of this is 1, plus the value that is in front of this is 1. That one is going to, the value in front of this is 2. 1 plus 1 is 2. Here again is 2. The moment you do that addition, you find out that the value you have on the left is the same as the value on the right. Tell the person that pressure has no effect on that system. So pressure has no effect when we have equal volume on reactant and product. Pressure has no effect. The second point says pressure will have effect on gaseous molecules only. So when you are given the reaction, you observe that all of them are in gaseous. That means you see small g in bracket. Here again you see small g. You see small g here. At that point you go ahead to discuss pressure. Pressure will have effect on gaseous molecule only. If somebody says a compound now A plus B producing, let us say 2CD, and somebody advance here solid, put in bracket liquid here, put in bracket liquid. Tell the person that pressure has no effect on that. Don't even waste your time. Simply because they are solid or liquid. Pressure only affects liquid, gaseous molecules, and not liquid and solid. Pressure has no effect on liquid and solids. We move. Let us now look at one case in which we'll look at an example of this particular analysis. Let us look at this form. Still under the Haber process, let us say nitrogen combines with hydrogen here to produce, they are going to produce ammonia. When nitrogen and hydrogen react under the Haber process, they produce ammonia. I will try now to put figures in front to balance the reaction. Let us say we put 2 in front of this, we put 3 in front of this. Now all of them will be gaseous. That means there is a gas here, there is a gas here, there is a gas here. Now the moment they are in that form, you have the right now to discuss pressure on that. If you are asked to explain the effect of pressure, you observe that all of them are gaseous. In this case, this is a gas, this is a gas, this is a gas. You have got the right to discuss the effect of pressure. Now when you want to discuss the effect of pressure, the first thing you do is you add the volumes that are in front. When we come here, we have 1, that is 1 volume. When we come here, we have 3 volumes in front. When we come here, we have 2 volumes here. 1 and 3 will give us 4 volumes on the reactant. And here we have 2 volumes here. Now when you look at it, the volume on the reactant is higher than the volume on the product. That means 2 is greater than 4 is greater than 2. Since 4 is greater than 2, we have the right to say the volume at this point is, the volume here is higher and the volume here is very low. From the analysis, 4 is greater than 2, so the volume is increasing here while the volume is very low at that point. The arrow here tells you that the volume is high, that is why it's pointing upwards, and this one is telling you that the volume is very low, pointing downwards. Now, what comes to mind? We'll go to Boyle's law. We said for you to be able to advance the effect of pressure, you look at Boyle's law. Boyle's law says when the pressure is high, the volume must be low. And when the pressure is low, the volume must be higher. So both of them will not increase at the same time. When the volume is high, the pressure will be very low. And when the volume is low, the pressure will be very high. When you look at this one, the volume, we already know that the volume is very high at this point. So the pressure must be very low. When you come to this one, the volume is very low. So we expect the pressure to be very high. That is why what you do. Anywhere the volume is high, the pressure is low at that point. And anywhere the volume is low, the pressure is high. That is the point. Now we go to Le Chatelier's principle. Le Chatelier's principle now states that if any of the factors that affect equilibrium is altered, like in this case, they have altered the pressure. The pressure is low here. The equilibrium will now readjust in order to lessen the change. Now, here, the pressure is very low on the reactant. It's very low. So when it is low, equilibrium will increase it. When it is high, the equilibrium will reduce it. So since the pressure is very low at this point, for you to go to the forward, that means for you to maintain the forward reaction, you increase the pressure. You say increase in pressure favors forward reaction, That means When you want to go this way, that is the forward reaction. You move from here, you go this way. When you want to go this way, the pressure is very low. According to the Chatelains, when it is low, you increase it. So since the pressure is low on the reactor, you will not reduce it again. Since it is low, for you to go this way, you increase it. So increase in pressure favors the forward reaction. What about when you are at this point? When you are at this point, you want to go this way. The pressure is very high already at this point. Since the pressure is high, according to the Chatelains, when something is high, you reduce it. So according to the Chatelains principle, on the right, the pressure is high. So for you to go to the backward direction, you decrease the pressure. Since the pressure is high at this point, you decrease the pressure. You say decrease in pressure, favor the backward reaction.
Space.
Receiver.